that's just made out of kind of the leftovers from the star formation. And then that disk, the individual bits of dust will collide to each other and they can sometimes stick together. We don't really understand that yet. Sometimes they stick and sometimes they bounce off, and no one really knows how they can stick together enough to start to form a planet. But then as soon as you have a big core, we call it a planetesimal, so it's maybe 10 kilometers across, that's big enough that its gravity starts to scoop up all of the rest of the nearby stuff, and then it kind of slowly picks up more and more bits of dust and gas, and they fall down onto the surface, and eventually it grows into something like Jupiter, or even bigger than Jupiter.
I'm Professor David Tseng, and I study transiting exoplanets and their atmospheres. Well, hot Jupiters are gas giant exoplanets, but they orbit much, much closer to its star than Jupiter does to our own sun. In fact, they orbit so close that the day side of the planets are heated up to thousands of degrees Kelvin. And because they're so hot, a lot of the atmosphere around the planet actually evaporates off, sort of like when a comet gets too close to the sun, you see a lot of evaporation of the comet happen. A similar process happens for these planets. They orbit so close, a lot of the atmosphere is being blown off. Because these planets are so close, we expect them to be tidally locked, which means the same part of the planet will always face the sun. And what that does is set up a very large day-night contrast in temperature. It's very hot on the day side, and it will be quite a bit colder on the night side. And this will in turn create large-scale weather patterns around the planet. This planet is so close that the tidal gravity is starting to distort the planet itself. If this particular planet was any closer, it could actually break apart.
But what might it look like inside the atmosphere of one of these extreme gas giant exoplanets? Let's find out.
I'm an exonephologist, which is someone who studies clouds on extrasolar planets. So what we're looking at is planet Osiris, otherwise known as HD 209458b, and these are extremely strong winds. Going from the west to the east of the planet, from the day to the night side, the wind speeds are reaching about 5 kilometers per second, which is about 10 times faster than Concorde. Osiris has a temperature of around 1,000 degrees centigrade. With these temperature ranges, we're not really looking at water clouds like we have here on Earth. But at these much higher temperatures, we have the sort of evaporation and condensation cycle of things like iron and silicates. So these planets might actually have molten iron rain and silica or glass rain, which is incredible because with these wind speeds of 5 kilometers per second, you're effectively going to be lacerated by this glass rain and molten iron. So these aren't particularly great places to visit.
My name is Nathan Main, and I study the atmospheres of planets we've discovered around distant stars. Our next destination is the surface of a water world. This is a super-Earth, as it's called. In our own solar system, we have no planets which exist in the size range between Earth and Neptune, but actually, as we observe off into the galaxy, we find this is one of the most common form of planets. We think that many of these have kind of rocky cores. They're terrestrial planets essentially, but they're likely to have a huge ocean. Now they're super-Earths. They're much larger than Earth. They might have much stronger gravity, and they probably have much thicker atmospheres. That means any land features that are on these planets, any rocky features, are going to be weathered and suppressed and effectively destroyed. You can see the surface is being distorted by huge waves. There's many reasons that could cause these waves. You have an ocean which is not interrupted by land masses. So many of these planets we expect could have moons or multiple moons even, which create the same tidal effects that our own moon causes in our oceans on Earth. Additionally, actually, many of these objects might be undergoing significant tectonic activity beneath the surface of the ocean, and these waves have no land mass to crash into, so they really can build to quite substantial sizes. Our next destination is the surface of 55 Cancri e. This planet orbits so close to its central star, it's incredibly hot. We think temperatures of a few thousand Kelvin or a few thousand degrees. We know from how much this planet wobbles its star due to its gravitational interaction that this planet is about 8 times the mass of the Earth. And we also know from its sort of transit, when it eclipses the central star, that it's probably about twice the diameter of Earth. So this planet is incredibly hot and has a very strong gravitational field. So what you can see is a molten lava field underneath you, where the surface is being disrupted and melted, and much of that material could potentially be lofted into the atmosphere. And what you end up with is a very soot-laden atmosphere full of particulate matter, molten rock and condensing rock, and raining sort of silicate particles. And you're going to have huge amounts of charged material flowing in the atmosphere, and that will lead us to have significant thunderstorms. So effectively, this is a pretty nasty place, probably as close to Dante's Inferno as you can imagine, with a molten lava surface, raining rock, and constant planet-wide lightning storms.
My name is Jessica Spake, and I'm interested in studying exoplanet atmospheres. TRAPPIST-1e is a fascinating system. It was a wonderful surprise to find 7 fairly Earth-sized planets so closely spaced together around this tiny star. The star is actually about the size of Jupiter. It's really like a solar system in miniature. So here you can see the stars a lot cooler, redder and smaller, and you can see it actually looks very big in the sky here. That's not because the star is bigger, that's because the planet is a lot closer to that star than we are to the sun. So these planets can be very close in and still be kind of about the same temperature as Earth.
We have discovered over 3,000 exoplanets, but we've only searched less than 1/1,000,000% of our galaxy. There are billions more worlds out there for us to find in the Milky Way, and billions more galaxies beyond our own. Each new planet we discover changes how we view the universe and our place within it. But so far, we've only found one, planet Earth. Thank you to everyone who helped to make this video possible. If you enjoyed it, please share, subscribe, and check out our previous videos. Thanks for watching.